Good morning. My name is Juliana, and this is Ethan, and we're going to go over communications. Computer communications, connectivity, wireless revolution, and communication systems. I will start off by discussing computer communications. My partner Ethan will dive into connectivity, the wireless revolution, and I will close off our discussion with communication systems. So, computer communications is the process of sharing data, programs, um, information between two or more computers.
What exactly are some of the examples?
Good question. The most common forms of computer communications is something we use day in, day out, texting, um, emails. This morning I emailed Dr. Lizette about um, being able to attend at a timely manner or at our lecture. Video conferencing, which these past couple of years, due to the pandemic, you guys have seen has been more used, and electronic commerce. I have Amazon Prime, so that makes it all the more easier for me to go and shop online. It's becoming a big thing nowadays.
In order for computer communication to be possible, connectivity is important. Connectivity is a concept related to computer networks to link people and resources.
Okay, so like without connectivity, it wouldn't be made possible for us to be able to communicate between one another using a computer, right?
Right. For example, connectivity means that you can connect your cell phone to other devices and information sources from almost anywhere.
So after that, then I guess we've noticed like a drastic change in how we use these communication devices, right? Like what's something that started happening like after the development of the internet? Like what spurred on after that?
So, shortly after the internet was created, the biggest development in it was the wireless revolution. The wireless revolution was the single most dramatic change in connectivity since the development of the internet and has been widespread use of mobile devices like cell phones and tablets with wireless internet connectivity.
Oh, okay. Well, so now I don't have to like be too mindful of someone's schedule. It's like, oh, well, will you be close to like a landline? If I want to call them, I can just simply like send them a text. Apart from that, it's was it like a couple of years ago, cell phones were just meant for calling, right? But now I can send text messages, I can email someone, I can even browse the web, right? And then I guess it's fair enough to say, I want to say that like the wireless revolution is over with, but it's constantly changing, isn't it? Like it's becoming a bit more efficient, right? And so there are communication systems in which make the actual communication between computers possible. Electronic systems that transmit data from one location to another. There are four types: sending and receiving devices, connection devices, data transmission, specification, communication, and communication channel.
I don't have any.
One, I guess you could say, kind of like to better explain how these systems work together is like if you want to send an email, or in this case, because we don't usually send emails to friends, but if you want to send a text message to a friend, you're using your cell phone, right? So that would be considered your sending device. And then the microchip that's located inside your cell phone, that's the connection device that would modify and format the message to travel efficiently through the communication channel, right? And then all of this information is traveled across the internet, and then it lands to your friend's cell phone, which is the receiving device. That's pretty much essentially how all these communication systems work together. But thank you very much for chiming in. This is all that our team has to discuss on communications.
All right, good morning, everybody. Today we have Matthew A and Matthew B that are going to be discussing connection devices and connection services. So, Matthew B, what are some examples of connection devices? Yeah, Matthew A. So, there are a few different types of connection devices. One of the main ones we're going to be talking about are what they call modems, which are devices that enables digital personal computers to communicate across different media, including telephone wires, cable lines, and radios. And so to go a little bit further into that, we have three different types that we're going to be talking about. And so the first one is going to be a DSL. Let me interject, Matthew B, but what does DSL stand for the viewers that don't know what that means? Yeah, Matthew A. So DSL stands for Digital Subscriber Line. And what it is a modem that uses standard phone lines to create a high-speed connection. And then another one is going to be a cable modem. And so that uses the same coaxial cable as your TV. And just like a DSL modem, a cable modem creates high-speed connections as well. And then the third type is what they call wireless modem, which is also known as a wireless wide area network, or WWAN. And almost all computers today have built-in wireless modems. Yeah, so with that, you said almost all. So what about the computers that don't have built-in wireless modems? Yeah, so for the computers that don't, you can get you can basically get a wireless adapter card that you can plug in to your PC, and you can just plug it in with a normal USB, just like what I have at home. It doesn't have a built-in, it just plugs right in. You just set it right on top of your computer. Okay, cool. So you talked about connection devices, and so what are the connection services that go with these connection devices? Yeah, so for connection services, there's quite a few. There's 5 different kinds. There's the DSL, which again stands for Digital Subscriber Line, and it's provided by telephone companies using existing telephone lines to provide high-speed connections. And they have what they call ADSL, which is Asymmetric Digital Subscriber Line, and it is one of the most widely used types of DSL. Another one, the second one, is going to be cable services, and those are provided again by cable television companies using their existing telephone lines. Yeah, so why do they use existing lines? Yeah, so they mainly use existing lines just because it's cheaper to just use the same line that goes throughout neighborhoods, houses, apartments, instead of digging for new wires and new lines and installing them every time someone gets a new connection. Okay, cool. Yeah, and so then the third one is going to be satellite connection services, and they obviously use satellites to provide wireless connections, and these are going to be a little bit slower than your DSL because it's not hardwired into your network, but the advantage is it is available almost anywhere. And one very famous example of that I'm very familiar with is Starlink. And that's something that's kind of brand new, and they're launching a bunch of satellites in the sky and providing internet all across the globe currently. Yeah, and so then another one is going to be what they call cellular service, and I think we can all kind of understand what this is, and it's basically the services we use for our cell phones, and every cell phone in the world uses these cellular services, and it goes from anywhere from 1G to 5G. Yeah, Matthew B. So remind the viewers what the 1G to 5G stands for, because not a lot of people know kind of what that means or what it is. Yeah, so basically what it means is 1G is the first generation mobile telecommunications, and it just kind of goes from there. So first, second, third, all the way to fifth. And it started around the 1980s with 1G using kind of like analog connections. And then it goes to the 1990s with 2G using digital radio signals. And then in 2000, they came out with 3G, which allows the users to connect to the internet, which is something that had never been done before. With cell phones, normally it was just call, and then eventually it went into text, and then into internet. And then the fourth one is obviously 4G or LTE, and that just provides a faster internet access, kind of still providing the same kind of services as 3G, just a lot faster. And then today, most recently, they have 5G, and it's so fast that it almost rivals home internet, to the point that sometimes it's even faster than what some people will have at home. And then the fifth type of connection service is fiber. And we're not going to talk too much about that, but basically it's a fairly new type of technology within the last couple of years, and it provides an extremely fast download and upload speed for internet access. Well, yeah, thank you, Matthew B. You provided a lot of good information today about different kinds of connection devices and connection services. And then I think that's all we have for today. Just any questions or anything? No, I think we're good.
Good morning. This is Ian and Billy. We're going to be talking about data transmission. There are a couple of factors that affect data transmission. These are the bandwidth and the protocols. First up is the bandwidth. This is a measurement of the width or capacity of a communication channel, or in simpler terms, how much information can move across the communication channel in a given amount of time.
So you're talking about the bandwidth. So is there any kind of like bandwidth we're using nowadays?
Yeah, so for bandwidth, there are four types of them. They are voice band, medium band, broadband, and baseband. The first one, voice band, is also known as low bandwidth. This is used for telephone communications and, in the past, personal computers. However, it's too slow for most forms of transmission, so it has mostly been phased out. Medium band is more specialized as it connects servers and mainframes. It has a high data speed transfer and is used in businesses. Broadband is probably the most common type, as it is how we connect to the internet. Devices such as cable, satellite, DSL connect to the internet with broadband because a single broadband connection can connect several users for high-speed data transfer. And then the last one, baseband, connects computers that are close to each other but can only support a single connection. Could you tell me about protocols and the protocol for the internet?
Yeah. So for the transmission to be successful, sending and receiving devices must follow a set of communication rules for the exchange information, which are known as protocols. So protocols have two types. The first one is HTTPS, or Hypertext Transfer Protocol Secure. Is widely used to protect the transfer of sensitive information. And the second one widely used Internet Protocol, which is TCP, or IP Transmission Control Protocol, or IP, like Internet Protocol. And these protocols involve identifying sending and receiving devices. So every computer on the internet has a unique numeric address called an IP address. Because these numeric addresses are difficult to remember and use, so a system will develop to automatically convert the text-based addresses to numeric IP addresses. And they're breaking information into small parts or packets for transmission across the internet. So each package is sent separately over the internet to one common destination. At the receiving end, the packets are reassembled into a correct order.
All right, thanks. I think that's all we have for today.
Good afternoon. Hello, we're Guillermo and Joshua. How are you, Joshua?
Pretty good. What about you, man?
I'm doing great. So, today we're going to discuss computer networks with you. So, what is a computer network? It's a network that connects two or more computers or devices together to share information, resources, everything one it can share it with the other. And they come in a lot of different ways depending of what you need to use it for. There are a lot of different parts for them. We got nodes. Joshua, what do you think nodes are?
What I think nodes are. Well, nodes, I think that they're basically anything that can connect to a more like central device. What do you think they are?
Yeah, kind of like that. Nodes are everything that are connected to the network. You got a computer, you got a server, you got a router or a modem. All of them are nodes. They allow the transfer of information between everything. But in this, we also have a lot of different kinds of nodes. We got, for example, a client. So like a client.
Those basically that's basically like the kind of like the host, but it's like more like it's kind of like a guest, like at a ball or something, where they basically like ask to like use something.
Kind of like that. You go to Starbucks, you got the customer, they ask the barista to make something, and the barista gives it to them. The client asks the server or whatever other node in the network for information and uses it as well. You talk also about the host, right? I'm not really sure about what a host is. What do you think it is?
So like a host is basically like the person who's like basically the most responsible leader, who's like basically in control of like everything, and they basically are the ones who like set things up, like kind of like a host at like a game or something. They're the ones who like basically sets up everything, and they're basically like the ones who's like mainly the one who's like responsible for like everything going to plan.
So you could say like the client uses the network, but the host goes and sets the rules for it, right?
Right.
Kind of like that. All right. We also got the servers. Like we go back to our example in Starbucks. You got the guy behind the counter, the barista. He makes the coffee. So I'd say that coffee is like the information serves the client. The client goes to the server, asks for information, and the server serves it to them. Do you agree with that?
I totally.
Well,
So like next we could like discuss what about Wi-Fi versus
oh,
Ethernet.
all right. We talk about parts of a
Cables.
network, but we didn't talk about how these
How-
parts exchange information with each other. You want us to talk about Wi-Fi and cable, right?
Yes.
Yes. So the parts of the network can interact in different ways. You can exchange information through cable, which you connect the two devices through a cable, and they send information through it, right? Like it's physical. It's really fast. It's really fast. You can do it through copper cables, like in telephone
Fiber
lines,
optic.
right?
Yeah. You can do it through like fiber optic. You can do it through like single lines. But like mainly though, like you would mainly like want to use Ethernet mainly because it's usually much more faster, and it is also usually much more reliable.
Oh yeah, the Ethernet. They are like the copper wires, right? They take like two copper wires, they twist it together, and that's how they connect the systems, kind of like that.
Yeah.
Yeah, we got you talked about fiber optic. Do you know how they work?
Fiber optic, like they're basically just much more faster versions of like the regular Ethernet. Um, usually go at like higher speeds. So for example, they can usually go up to about um, like
Yeah.
1 billion bytes per second, and they're like usually used like on like big server farms.
Yeah, with fiber optic, if I remember correctly, what they do is they use like a crystal a glass cable, a small glass cable, and send like pulses of light inside of them. That's kind of crazy, right? You know, we use copper with like pulses of electricity, and then we go ahead and use send light through glass cube. In concept, it sounds crazy. Imagine telling that to someone in the 1900s that would send information through little tubes of glass. They,
Yeah,
they think we're crazy.
that is insane.
Yeah. So
What
yeah,
about your microwaves?
microwaves.
What
Oh
about
yeah,
those?
they use it to send information, but like through shorter distance. You know, like microwaves, they don't get affected by gravity. So like if you send a microwave in a straight line, it's not gonna go anywhere on Earth. It's gonna end up in somewhere in space. Kind of crazy, but you know, also we didn't touch upon wireless connection. You know, today everyone has a cell phone. They connect to Wi-Fi. You know how Wi-Fi works?
Wi-Fi works like mainly through like sending like multiple radio waves through like wide signals to a much more like wider area. So like basically, so if you have like a wall and like your router is like out like somewhere else, like that wall, it could like possibly affect the Wi-Fi strength, and it could like make your speed slower.
Yeah, that's kind of a limitation of that. If you have a lot of walls, it can become less responsive. It reminds me also of Bluetooth. Bluetooth has the same thing, but I'm pretty sure Bluetooth is shorter, like a lot shorter than Wi-Fi.
Is much shorter.
Yeah, and you know, Wi-Fi we use it to like connect stuff to a router and then connect to the internet. But Bluetooth is more like everyone uses Bluetooth for audio right now. And yeah, thank you so much for sticking with us today. We're happy to be with you. Have a good evening.
Alrighty, hello everyone. My name's Taylor and this is Jackie. Today we are going over network types. Go ahead and start off with the local area.
So local area networks are networks with nodes that are close in proximity. The span distance is less than a mile. Usually these are owned and operated by individual organizations, and they're widely used by colleges and universities.
So the LAN networks, are they just held to the specific buildings or?
No, actually. So there's these things called network gateways, and these allow one local area network to be connected to other local area networks or larger networks. Speaking of LAN networks, they are now being used by individuals in their homes and apartments, which are actually called home networks. And these networks allow different computers to share resources, including common internet connections.
Speaking of houses, most homes and most buildings in general will have a wireless LAN. LAN stands for local area network. Uses for this are, so it uses radio frequencies to connect to computers and other devices. All communications pass through a centrally located wireless access point or a base station. It provides internet connection in public areas. Those are typical hotspots. You can find those in public places like a Starbucks or sometimes like different food places or things like that. Next, we have personal area networks. These are wireless networks that work in very small areas. They connect things like your phones to your headphones, as well as like little wireless keyboards and things like that.
Okay, so I have a question.
What's up?
How big of an area are we talking, since you're saying very small?
We're talking like your immediate area, with the max range being around 33 feet. It's not that big. It's really just less than your eye can see, probably.
Okay, so that's super different from metropolitan area networks, which has a span of 100 miles.
Wow.
They're frequently used as links between office buildings that are located in a city. Usually these are owned by a group of organizations or by a single network service provider that provides network service for a fee.
Wow. So even though that's a super large area, 100 miles is huge. But I mean, we still have wide areas, which these actually cover countries and worldwide. Provides access to regional services and typically spans distances greater than the 100 miles. They use microwave relays and satellites, and we call them wide area networks, but internet is also a good way to call it because it connects you from one side of the world all the way to another. I believe that's all we have for today.
Yeah.
It is. Alrighty, everyone. Have a nice day.
Good afternoon. I'm Jonathan.
And I'm Nathan.
And on this episode is Network Strategies.
So, network architecture describes how a network is arranged and how resources are coordinated and shared. One of the many networks is bus network. And essentially, each device is connected to a cable called a bus or a backbone. And all communications travel along this bus. They are commonly used in a lab or office. The second network would be a ring network, which each device is connected to two other devices, forming a ring. When a message is sent, it is passed around the ring until it reaches its intended destination. The third network would be a star network, where each device is connected to a central network switch. Whenever a node sends a message, it is routed to the switch, which then passes the message along to the intended recipient. The star network is the most widely used network used today. It is used from homes to large corporations. The fifth network is the tree network, where each device is connected to a central node, either directly or through one or more devices. The central node is connected to two or more subordinate nodes that in turn are connected to other subordinate nodes, and so forth and so on, creating a tree-like pattern. Tree networks are often used to share corporate-wide data. The sixth network is a mesh data network. This is a new topology that doesn't use a specific kind of layout like a star or tree. Instead, the mesh network requires that each node have more than one connection to other nodes. So if a path between the two nodes is disrupted, the data can automatically be rerouted around the failure, and wireless technologies are commonly used to build mesh networks.
And then next is clients and or servers. A client can use central servers to coordinate and supply services to other nodes on the network. The servers can provide access to resources such as web pages, databases, application software, and computer hardware. A good example of this is by programming a Raspberry Pi that can be used as a server in the game Minecraft. So by doing that, you can play whenever you want instead of having to wait for that intended friend. The next one is a peer-to-peer network that are equal authority and can be used as a client as well as a server. One of the most popular ways of a peer-to-peer server is game sharing. So for this example, say you want to play with your friend who doesn't own a game. By sending them an invite to a game share, you are sending data from your own console to theirs, and if they accept, that console downloads the info from the cloud and allows them to play as the second player.
Wow.
However, this isn't always a good idea because some game sharing or some peer-to-peer applications do not have good security and are often an intended target for malicious hackers that could eventually get your IP address and all of your personal information.
That's not good.
All right. Thank you for listening.
Thank you.
Have a great day.
Hello, everyone. Welcome back to another episode of Computer Essentials. Today, we're going to be talking about organizational networks. In the studio today, you have Tim and Anastasia. How are you doing, Anastasia?
I'm good. How are you?
Doing pretty good. Are you ready to talk about this technology?
Yeah.
All right, let's go ahead and do it. I'm going to talk about internet technologies. Many organizations today employ internet technology to support effective communications within and between organizations using intranet and extranets.
Okay, and what's the difference between the two?
I'm glad you asked. I'm going to tell you I'll tell you first the intranet, which is going to be a private network that is within the organization that resembles the internet, like the public internet, but it uses security within the organization itself, and you can use browsers, websites, web pages that the organization sets up that they deem are okay to go to. And then they also have applications which include electronic telephone directories, email addresses, employee benefits, and information like job openings and that sort of thing. Now, the second part of your question, the extranet is a private network that connects more like more than one organization. Many organizations use this technology to allow suppliers and other limited access to their networks. This increases efficiency and reduces costs. I don't know if I told you, but my wife actually works for Hewlett-Packard, and she works in the hard drive department. And within there, they use both intranet and extranet. So their team uses the intranet for different communications, and then for her suppliers and stuff, they'll use the extranet, which works really well.
Okay.
Yep.
Yeah, so I hear you talk about a little bit of security. So I'll dive deeper into that. So big organizations want to ensure that only their authorized users have access to the network resources. So to help with this task, they use specialized technologies.
So Anastasia, what type of specialized technologies?
Okay, so there's 4 major ones that they use. The first one being firewall, which is a hardware and software that controls access to a company's intranet and other internal networks. And they do this by using a proxy server. A proxy server is a software or special computer that evaluates the source and content of all communications between the company's internal networks and the outside world. Then the server decides whether it is safe to pass through. And another one is the intrusion detection systems, also
and what
called,
exactly does that do?
that's the ADS,
ADS.
as well. And it works with the firewall to protect a network. The IDS uses sophisticated statistical techniques to analyze all incoming and outgoing network traffic. It can recognize a network attack by using these advanced pattern matching and heuristics.
That's very cool.
Okay, and could you explain to me what a virtual private network is?
Sure, yeah. A VPN creates a secure private connection between a remote user and an organization's inter-network. Special VPN protocols will create the equivalent of a dedicated line between a user's home or a laptop computer and a company server. The connection is heavily encrypted, and from the perspective of the user, it appears that the workstation or whatever they're working on is actually located on the corporate's network. All right, you have anything else today?
No, I'm good.
All right, thank you guys for listening to our podcast. We'll check you out in the next one. Thank you.